All right. Welcome everybody. Thanks for showing up. We've got a stream going, and we'll kind of take you through the agenda here today. Real quickly, we did the welcomes, and so we kind of, I'll just say we kind of got through that part already. What we're going to do is we're going to talk a little bit about a couple things that happened during this week, or I'll introduce someone in the meeting today, and they'll talk about something they're doing. And then we're going to kind of work through the tokenization AMA and try to see if we can figure it all out. And if we have time, and I doubt we will, we'll talk about the DAO. And in fact, the DAO meeting that was actually happened before this. There was a DAO meeting, so probably won't get there, but I can assure you we have more than enough to talk about. So Camus, are you here?
Yeah, I'm here.
All right, cool. Hey guys, a really interesting initiative that's going on, a new Discord server and a new project. And I recently joined it, and I wanted to allow Camus to kind of talk about what he's doing with this project in his group. So I'll kind of hand it over to him. So one of the things before I do that, I just like, the Americas group is here just to introduce and help support projects or new endeavors that are happening in the community. That's all about helping build the community. So if anybody has anything they want to introduce or talk about projects or whatever that they're thinking about forming or are actually forming, just let us know, and we'll give you we'll let you have some airtime. So take it away, Camus.
Sure. So this is very much a new kind of idea, a new community that's coming together. So it's very mutable, very open to change. But I proposed kind of I don't know if you guys are following the DAO manifesto thread, but I proposed a DAO there, and I've gotten a couple groups or a couple people together already, like Greg, and we kind of just have this idea of an open source decentralized finance DAO, so DeFi. And it kind of comes with the idea that DeFi is really changing in the broader crypto arena in general, and IOTA hasn't really been exposed to a lot of those different apps that have been developing and changing for the last couple of years. So we just envision building kind of like a community learning, working, and governance organization where interested people can come to learn and develop together towards new and innovative DeFi solutions. And kind of the underlying ethos here is that it's all open source, everybody's collaborating together, and it's a community that's building these solutions for the IOTA environment itself, as opposed to people coming in like Uniswap or SushiSwap or somebody else coming into this environment with the primary goal of sucking out as much liquidity from our environment as they can. So just a bunch of like-minded people who are interested in learning and developing, just cobbling and seeing what we can build together. And kind of initially, our goal is to build something similar to the Olympus protocol. You might know it as. It's become like a really popular idea out in kind of the Ethereum space. That's not exactly where our end goal is, but that's just the primary goal, to get something built on the smart contract testnet. And then the whole idea is to have a DAO kind of governance structure, so that everybody involved ultimately makes the decisions about when we have something built together, what do the next steps look like? How do we go about public auditing? What decisions do we make about implementation and all that kind of stuff? And it's really just this open source, innovative DeFi hub that I'm hoping to just get as many people in the space interested in, just get a lot of smart people in the room and have them talking and building together, and just kind of see what we can do. So to that extent, if you're interested, just reach out to me. I think there's a couple members already in this audience who may have something else to add if I miss missed anything, but yeah, feel free to reach out to me, and just hoping to get a lot of smart people together and build something cool. So let me know.
Yeah, I'll just say that there's a lot of talent in this group and a lot of people that have been experimenting and have kind of a broad reach and understanding of the space. And they're all interested in forming something new but built on IOTA, and also kind of compiling the best of what's out there and making that bringing that together into an IOTA based initiative. So if you're into that, it's pretty doggone cool. Tango Account's part of that as well. Just if you guys know him, he's part of it, and a lot of other people. I don't want to. I'll let them introduce themselves if they want to, because it's it's kind of that thing where people want, if they want people to know, they should let them do that. Okay. Anybody else that want to say anything about the group, or are we good to go and moving on to the big show here?
Sounds interesting. Ready to join.
Okay, cool. Camus, go ahead and make sure that you put your name and invite into the American channel so that people can just, have that as a reference if you haven't already done it. I think you have, but
Sure thing. I'll throw it in there right now.
Cool. Okay. All right. So after our last time that we did this, the AMA, the last AMA we had on smart contracts, people seemed to really like the approach of looking at snippets of the video and then having us do pauses at different timestamps and then kind of trying to talk about it because, there's a lot to understand. So we're going to do it again, kind of by popular demand, especially on this one. A lot of people got excited about it. And before we get into it, I just want to thank Ben a whole heck of a lot. Ben went out and put together a nice spreadsheet for me on timestamps, and I had actually done it, and I had it all written out, and I hadn't put it to a spreadsheet yet. So I was looking at mine and looking at his, and it was almost identical. So I just ran with his and added a couple. So that was really helpful. And I might add, when we're going to do this again in the future, if it would be really helpful for you guys to help me out doing this, because it's quite a bit of work to do all this stuff and keep it always going.
Hey, man, no problem. That was my pleasure because I wanted to look at it again because there's just so much new, exciting stuff there. I'll do it again.
All right,
right
cool.
Now.
All right, cool. All right, so Dave, why don't we? How do we want to do this? Yeah.
Well, let's just see. So everyone can see the agenda out there, correct?
Yep.
Okay.
Yep.
Let's see if this works here.
Always, yeah. Here we go.
Okay, I've got everything one click now, so hopefully I've done this right. So based on that, let's go to the first one. This is hybrid layers is the subject.
For example, are example of that. You can program a smart contract chain in IOTA the very same way you program Ethereum. So it gives you the option as a
no
developer
audio.
to choose. Okay.
No audio.
No audio. Yep.
Interesting. Okay. You guys don't hear the audio?
Make sure to share the window, not the whole screen.
Ah, okay. Let me go ahead and try that then. Let me go ahead and I'll redo this share then, and hopefully that'll solve this.
Cool. Yeah, Dave actually went to a lot of work on this. I really hope it works. He got the audio in there for him because he's done such a good job on it. All right.
And smart contracts, for example.
All right.
Does that sound better?
Yes, sir.
Who was the guy? Who was the solution master on that one? Who told me that solution?
Yeah, it's me.
Thank you. Thank you very much. All right, here we go.
Are example of that. You can program a smart contract chain in IOTA the very same way you program Ethereum. So it gives you the option as a developer to choose, okay, does my use case require this advanced programmability? If yes, then probably you should do it on a smart contract chain. However, if my use case requires feeless transfers and ultimate freedom, then why not do it on layer 1?
Yeah. Yeah, I mean, the whole idea behind this is to really offer freedom and flexibility to the developers, because we have layer 1 and we have layer 2, and with unique USPs on each layer. But I think the beauty, like what really clicked for me when I was thinking about this, was how both can fit so beautifully together, right? How layer 1 tokens can be wrapped onto the layer 1, and how they can actually secure and actually connect the different smart contract chains. Because one of the difficulties that, for example, all the wrapping solutions on Ethereum have today, and also what the sort of layer 2 solutions on Ethereum have, is this interoperability problem. How do you go from one layer 2 network to another layer 2 network, right? There's no way for them to easily transfer assets. Now with our solution, we actually use IOTA as a data/token transfer layer, right? And they can do it feelessly between each other.
I'm assuming that's a good stopping point there.
Yeah. So, my take on that is it's pretty simple. That one's probably the easiest one to explain, right? But it's just layer 1, allows you to connect and this hybrid thing. What did I write down?
Hybrid layers.
Yeah, hybrid layer. So layer 1 takes and connects your smart contracts. What was my note here?
And I think for me, what it means is that
got it.
It connects the smart contract layers with the layer 1, which is the kind of anchor layer, and they can move seamlessly. Whereas with stuff like Ethereum, you have to do things, especially because of the cost. You have to do optimistic rollups and all kinds of other machinations to get from the layer 2 stuff to the layer 1. Whereas with our solution, ISCP, it's very seamless and it's very cost efficient. And with the new RFCs in place too, it's only going to be more, because that allows a lot of different interactions to happen.
Yeah, and with layer 1, right? That basically, trustless assets on layer 1 basically inherit all of the scalability and security that we're used to, right? And so that's kind of one of the big aspects here, and one of the key advantages that talk about. So, anybody else have anything to say on that one? I kind of couldn't even read my own writing. So,
I like to think about it with like cross-border interoperability too. So if you thought about it with stable coins, you could essentially have US dollars transferable to euros, and those would both be wrapped assets on their own implementations of IOTA, but they would be anchored into IOTA as the root chain. And then they would use IOTA tokens as the swap mechanism. So it's pretty much a seamless atomic swap that you can do between different smart contract networks.
Perfect.
Yep, exactly.
What he said. That's good. That was really good. Shall we go on to the next one?
Yeah. Okay, let's see how this works. I'm going to close that window and open the next one here.
As we call them, they are the tokens which live inside the IOTA layer 1 ledger. So these are tokens which are tracked in the very same Utxo framework as the network uses for regular IOTA transfers. Yeah. So any token which is present in this native token framework, that actually inherits all the security and scalability of the base layers, so IOTA. On the other hand, it also inherits all the permissionless properties of those tokens. So if you have a layer 1 token in your pocket, in your wallet, then it belongs to you and nobody else. It's not like there is a smart contract somewhere up in the blockchain which can freeze your assets or seize it or just stop trading at all. Like, it cannot happen on layer 1 that anybody is restricting your access to your own possessions. Right. And
is that where we want to end that, or is there more?
Yeah. So what timestamp are we at now? I can't see.
It is 2011.
You can take it through 22.
I think this is really
to
important.
39, 22.
So the other
39
form of tokenization, sorry, Dom, just to quickly finish it off, is what we call layer 2 tokenization. And this is what we mean when you tokenize stuff on layer 2 smart contract chains. So exactly with these new smart contract beta, for example, you can already do that. And I've seen already people, actually, I also deployed my own token on the beta network.
Leventicoin, Levicoin.
I don't remember how I called it. Yeah. But the thing is that when you tokenize stuff on layer 2 with smart contracts, then it is familiar to developers in the crypto space because it's just exactly the same as how Ethereum does it. So you have a smart contract, and the smart contract itself basically maintains a ledger inside the contract, which records who owns what. And then whenever you want to transfer stuff, then you have to call this smart contract and say, hey, modify the entry in your ledger. I sent my tokens to Alice or Bob. So this gives you a lot of freedom when you want to program what is possible and what you allow users to do and how you do it. It's really powerful. But on the other hand, this also means that you do it in an account-based layer 2 smart contract chains, which have similar scalability properties as other platforms as well.
Okay, cool. So kind of self-explanatory. Layer 2 basically takes you to this, gives you the same constraints that Ethereum has, but there's advantages to that. But we can actually, with our hybrid approach, we'll be able to, combine L1 and L2 and do things that the other guys can't. Anybody else have anything else to add about that, or does that make sense?
Yeah, so it's like regarding the previous comment that we can swap on the layer 1 seamlessly.
Yep.
So I would guess if I, for example, through a smart contract, let's say I issue a token, for example, through that I then want to swap, it would essentially, the swap would happen on the layer 1 and would be feeless, right? But I could also define specific fees to operate the smart contract, and of course on layer 2. I guess it would be helpful to understand how seamless the wrapping would work. Can anybody say something about that? The wrapping and swapping, I guess.
You want to take a stab at that, Phylo, or anybody else want to help us out?
What was the question? Could I hear it again?
So I was regarding the earlier point, right? I don't know who said it. Was it Dave? That we can seamlessly swap on layer 1 any asset for another asset, right? And I wonder, okay, there must be typically a smart contract that governs that, right? So I was wondering if somebody can talk about how that interaction from layer 2 to layer 1 and potentially back to layer 2 would work.
Okay, I think there's a misunderstanding here. It's not necessary to do it on layer 2. It can be done on layer 1 with the new way of unlock blocks and outputs. We have an ability to literally do everything by combining a few of those new unlock blocks and outputs on layer 1. We can create a timed output or a timed unlock. I don't know the exact terms from the top of my head, but essentially you put a request for a swap on the level 1, and for a certain time, and then if somebody acts upon that, he can send you the tokens to the same. He can spend the tokens by returning your tokens, and then the swap is automatic on level 1. If nobody is taken on that what you call it, a offer on the level 1 within that certain time frame, the tokens will automatically be returned to you. So
yeah. So it's basically, is it regarding the different output types that we have now and the ability to run?
Yeah.
Right?
Yeah.
Yeah, okay. And we'll good part at the a little bit further on where the video gets into that and the new output types because they're quite powerful. Let's okay, cool. Let's roll.
But let me if I can make one more point. I think
absolutely,
and I think what Eric was illustrating is that it can happen on level 1, but it also could happen on level 2. Is that correct, Eric? That you have a choice essentially, right?
Yeah, you do have a choice. The smart contract would probably outsource to level 1 as well.
Because that's more secure essentially than doing it all at level 2.
Yeah, it's a very simple mechanism to do that swap on level 1 because it's completely supported at level 1. So you don't need to do it at level 2. At level 2, what you would do is you would use the smart contract itself as the secure intermediary. We actually have something like that in our fair auction demo contract, where somebody wants to auction a token, and then people can bid on that token. So let's say it was an NFT, right? That people can bid on them, and then at the end of the bidding period, the highest bidder automatically gets the token, and all the other people who bid automatically gets their bid back. So the smart contract in that case functions as a custodian for the tokens while the bidding is going on, so that nobody can put any shenanigans in, and it's literally safe. And for example, the auction organizer can take his percentage from what the person who put the token up for auction is receiving. So that's the kind of thing that you can do at a higher level. Yeah? But for a pure simple swap of X tokens of X or X tokens of A to Y tokens of B, that is something that would probably be outsourced to level 1 because that's such a simple and an elegant solution for it.
Hey, Eric, right? Just write it here. I'm just kind of curious. In the beginning, before we had all this new goodness with this new tokenization, we were always worried about the development of bridges, right? It seems like we've pretty much eliminated a lot of requirements for having bridges, right? With this new approach.
As long as the tokens reside on the Tangle, right? So all the tokens are now going to be first-class citizens, and you can mint tokens of different tokens on the IOTA chain out of thin air. They can be used in anybody's wallet, right? They can be transferred as normal, just like the normal IOTA tokens, but they keep their identity, and therefore you can just use them and swap them and whatnot without any trust factor involved other than the Tangle itself. And of course, the Tangle is the trust factor.
Thank you for that.
What is the name of the tool again? Is the new output types?
Yeah, they're called new output types. It's a tokenization. Tokenization framework is what we call it, and it's just a matter of using the UTXO system in a way more powerful way than anybody ever envisioned it.
Yeah, it's really amazing. And I'm going to cut people off on that because later on we actually go through the RFC and we're going to look at those output types. So, okay, let's go on to the next one, 2250.
Okay. All right. 2250, or is that 26? The 4 output types, right?
Well, can you hit the bank cash one? Is that one on there? Do you see that? What did you have next? Let's go there. What did you have next?
Was I believe the 4 output types. I don't have the bank cash there.
Okay, let's go. Let's go with what you got.
Okay.
Output types. So in general, we introduce 4 new output types into the ledger, which are listed there as alias output, extended output, foundry outputs, and NFT outputs. Now, some of you, I'm sure, don't really get what an output is. It's actually a term which is used with the unspent transaction output model. So what it actually means is that the way the network tracks who owns what is by tracking each individual transaction and checking what inputs are used to fund the transactions and what outputs the transaction creates. So this is basically an accounting system.
Yeah.
So far, at what is currently live in Chrysalis, you only have, well, 1 or maybe 2 types of outputs, because the only use case which is possible is transferring IOTA tokens. So you don't really need much variety there. But as soon as you want to provide support for smart contracts and tokenization, well, suddenly you need to add more output types, which present special validation constraints to the network. So without further ado, maybe let's venture into what is in the document. These different output types will be discussed later.
Yeah. You want me to go? Yeah.
It's okay like there. Yeah. So the first part was mainly about motivation. And this is just an introduction into what we already talked about, the ledger programmability with Bitcoin scripts and Ethereum. And we also mentioned, I guess, Cardano there, because they're doing really great work with pioneering these Utxo programmability concepts.
No, we should definitely talk about that afterwards, by the way, because I think it's important to also draw some.
Okay, I'm going to stop it there, because I think we went a little bit over on our time for that. But the 4 output types, and he doesn't go into the output types in here, but I think later on he goes into and describes each of the different output types.
Yeah. Somewhere along, we missed something, I think, but he was talking about layer 1 being kind of, you should consider it like being the bank. Or no, smart contracts is. Actually, I'm going to ask Eric about this. Eric, do you know the bank and cash description?
Yeah. So the cash are the fungible tokens essentially, right? And the moment they are in your wallet, they function as cash. And the moment you put them under control of a smart contract, then they become like a bank account. So you have the tokens no longer. You don't have the access to it. It's the bank who has the access to it and who keeps track of them in their account. And then the moment you want to withdraw the tokens, you can do that. Right, so you still have the keys necessary to withdraw them in a secure way, so nobody else can access your account. You're the only one who can access it through the public key or the private key of your address, because they're literally stored under an address that is under your control in the smart contract. But they are being kept in an accounting system, so it's just a matter of X tokens of a certain type, Y tokens of another type, and Z tokens of yet another type, right? Instead of a bunch of UTXOs that all could hold tokens of those types and all together form the amount. Right, that's what, if it's on the Tangle, they can be spread out over multiple wallets or whatnot, right? And yet still belong to one person or one entity. And when they're inside a smart contract, all the ones that are connected to a certain address, and actually one person can have multiple accounts even if he wants, right? If you want some anonymity, you can spread it out over multiple accounts and work with the multiple accounts. It makes things a bit harder for your life as well, I would say, but it is definitely possible. So the transferring from when you put it in the bank and withdraw it from the bank is literally when it goes to the smart contract and when it comes out of the smart contract. And then they are there. And that goes for all the tokens, right? So also the new tokens that we're going to have, tokens that are minted, the NFTs, etc. They all behave like the normal tokens on the Tangle, and so they can be inside your wallet, and that at that moment nobody else can touch them or do anything with them. It's only that when you put them in a smart contract that you can do special things with them. Like, for example, the example that I put up earlier, where you put it into an auction up for sale, for example. Then there's temporary custody by the bank, and then once the transaction is done, the people can decide whether they want to withdraw it from the bank or not.
Gotcha. Cool. All right, David, let's go to the next one.
Okay. That's going to be provide hard-coded configurable scripts in your transaction for tokenization. Okay.
You don't have to pay to miners or validators to include your transactions in the ledger. But as a consequence of this technical concept, we have to be overly restrictive on how we can program our ledger. And the route we chose was basically to provide hard-coded but configurable scripts, which you can include in your transaction, which support aforementioned use cases like tokenization and smart contracts. I can imagine in the future maybe more, not just more use cases, but also advanced programmability, but it will require us to rethink a little bit about the architecture. Anyway, what's good about this approach, and what you highlighted over there, is that it keeps layer one as scalable as it can get, and also enables us to provide really big support for anything on layer two, like smart contracts or any virtual machines. So it doesn't matter if your virtual machine is based on EVM or VESM or whatever, you can easily integrate it with these new output types.
Okay, cool. So pretty extensible, sounds like, right? Pretty powerful stuff.
What I maybe wanted to add, because like he's talking about this, that we have to restrict the layer one in some way, because others you could think like what Cardano is doing. They because they don't have kind of level 2 smart contracts, so they have implemented their smart contract solution in the UTXO with this extended UTXO thing,
right?
And so they have actually theoretically all the or most of the functionalities that like an EVM or level 2 chain has on the Cardano layer 1, but they have fees, yeah, and so they will charge fees according to how much computational resources you need to execute those smart contracts in those UTXO scripts. And so they can just charge, if you have a very, very extended and a very complex functionality programmed into this UTXO on Cardano, you will have to pay a lot of fees for that, because the validators actually will have to offer those computational resources to make these operations on level 1. But as we don't have fees on level 1 and we don't want fees on level 1, then has to be a restriction on the functionality and on especially on the size of data and the stuff that is happening there. So this is why they came up with this, like I said, pre-configured, but like
hard-coded
preset but configurable, right. Yeah, hard-coded, but it's still configurable. So there is some hard-coded limits, especially on the size of how big, because we don't want to have a transaction being bigger than 32 kilobytes. But inside this framework that is offered, you can configure a lot of functionality that is needed. And so it's not overloading the nodes on level 1 with computational complexity, and still offers a lot of the functionalities of simple smart contract functions that they will explain later in the output types. So I think it's a great solution of bridging both worlds and taking actually the best of both things, because in Cardano it can, I'm pretty sure they will run into pretty high fee problematics with their smart contracts on level 1, because they offer this very broad and very high usage of the UTXO on level 1, and they will run into fees, but we will keep level 1 feeless and still offer a great functionality with this output scripts there.
Thank you for that. Yeah. So they were also talking about Turing completeness and right, and this is the way to address not being Turing complete, right? So that was.
It's like giving you some building blocks or templates that you can parameterize, but not giving the full the user the ability to create huge and cost inefficient smart contract code that runs at level 1, because that would cost too much processing power and too much time to validate everything.
Bury the network. Yeah.
Without fees, you just could program a loop actually that kind of runs endless in your
DDoS the
Utxo
network,
script.
really, essentially.
Yeah, actually, it's an attack vector that you, without having a cost involved for the transactions, you could easily kill a feeless network with things like this.
Yep.
In Cardano, it will cost you a ton of money to run such expensive scripts, and then you will quickly run into problems that you think like it's kind of useless attacking this, because it will just cost you a bunch of fees to do that.
Yeah, cool. Hey, Dave, before we go to the next one, can you tell me what time segment we're on? Because because of this way I can't see.
Oh, sorry. So let me do this. Can you see now? So we are on right here on line 7, which is provide hard-coded configurable scripts in your.
Yeah, no, I'm just looking at times. What's the next time segment that we're going to go to? Do you remember?
Oh, that's going to be 3040 to 3250.
Okay, cool. Thank you.
Can I add something for the previous topic? Because
yes, please.
There's something that is under highlighted, in my opinion.
Okay.
And that is the difference between an account-based system and a UTXO-based system for distributed ledgers.
Good point.
The fact that you have an account system, then you cannot split it up easily into separate groups unless you start using multiple addresses, and then you need to keep multiple accounts. For each address needs its own account, right? With UTXOs, you can have multiple token sets on a single address, and you can split them up very easily. And what is under highlighted is the fact that we can do that in parallel. Right? The blockchains have to serialize all those transactions, where we can do it in parallel. So our system is way more scalable and way more parallel than the other systems, because we don't have to look at that. It's automatic. It comes from the Tangle itself, that multiple transactions can be processed at the same time, and you don't have to wait to fill a block and then process them all in sequence and then wait for the next block. And you just start processing them, and all those smart contract chains are running in parallel without interfering with each other, and the communication happens through the Tangle. So the scalability aspect is, in my opinion, under highlighted ridiculously.
Yeah, absolutely on that. And just for those that may not be aware, the accounting approach that You're speaking about that. That's the Ethereum world, right? So.
Yeah, for example,
right.
There are multiple chains that use accounting instead of UTXO.
Right.
And for example, with Bitcoin, they have UTXO, right? Also nice, but they don't have the possibility to exploit the fact that they have UTXOs in the way that we are doing it now.
Right.
We're literally taking that to the next level.
Yeah.
Right. Yeah.
Yeah. Cool. Thank you for that, Eric. That was very important. That's why we have you here. All right, David, let's go to the next one.
Okay. All right, the next one is, all right, new transaction rules, different conditions at 3040.
Okay.
There, please, with the table. So this is quite an important change. So basically what we do is we update how transactions are processed on our network. And this means that we add new rules to how transactions can or should be validated. And as a consequence, we sort of had to fine-tune a little bit our Chrysalis concepts. Nothing changes big time. It's just rather some small little changes. But what is most important, as you can see, this is a structure of a transaction in IOTA. And the outputs, the list of outputs which are supported, actually there are now 5. So previously we only had the thing called simple output on the bottom. Yeah, you can do that. So that is what our current mainnet is capable of doing, transferring IOTA coins. And with all these new output types, which we will discuss later, we basically make the ledger more feature rich, and we add a lot of utility to it. So this means that we had to a little bit adjust the protocol as well.
Just really quick a question. Each of these output types has different conditions that need to be met for the transaction to be validated in the network, right?
Yes, exactly. So depending on what outputs are present in your transactions, different rules might apply. So this is actually how you as a developer can take the best of this framework and just use whatever you need for the use case and configure it, and then also be able to tailor it, because it's one thing that there is an output type, but basically depending on what you put inside an output, what parameters you put there, what addresses you put there, you can modify the behavior quite a lot. And I think that is a powerful concept here.
Cool. So yeah, now you're seeing this, setting the stage for. On top of this, we have a parallel pipe scenario that Eric just spoke about, but now you're starting to see us extend the data types to the point where they have new capabilities and attributes, and the power you're going to see as we kind of move to them just becomes apparent, and you'll start seeing why this is a hell of a thing they put together here, and how we're going to be able to, in my mind, leapfrog over everybody else. So anybody else? I mean, I don't know if there's anything more to talk about. That is pretty straightforward. I think. Go ahead.
I just really wanted to. I maybe just wanted to add really that it's really important for everybody that is looking for, let's say, like they said, utility of the IOTA token. How important this is. I mean, we as a community, we're always kind of happy. We have feeless transactions, we have fast transactions, but that's actually all you can do with the IOTA token in the moment. You can, of course, send data transaction, and we have cool data use cases, but for the pure IOTA token, the only thing you can do is sending it forth and back for free. And these 4 new output types, they kind of multiply the utility and the use cases of the IOTA token in such a tremendous way, and of the network, because for all these IOTA tokens, for all these use cases, you will directly or indirectly need IOTA tokens. You need to own them, you need to transfer them, you need to move them in the Tangle, and so you can with this little thing, we have kind of put 400% more utility to our network just on the base layer, even without smart contracts. Yeah, this is like such a huge thing that is, I think,
incredibly powerful.
Until you see it live, it's kind of still hard to envision how much new stuff there will be possible with the Tangle, and are really not possible with any other DLT that is out there in the moment. Yeah, I'm just getting super amazed to see this going live on the testnet first, and then I think the community will go kind of pretty crazy to find out what is possible now. Yeah.
I mean, it's almost like you're able to morph, or when if I'm a programmer, I say abstract, but I don't know if everyone here's a programmer, but you can morph it into other things, and that therein becomes extremely powerful. You can morph it into an NFT token. You can morph it into, in many other ways, and so then the IOTA token becomes an anchor, but it can be treated like many other different ways, and that's what's so powerful about this.
So
yeah, you would want to see it in a slightly different light. Each output type solves a very unique problem. It's a very simple, well-defined, unique problem, and you can use composability to combine the features together, right? If you look at this list,
feature, Eric, I will say we refer to composability a lot now in all our discussions from communications from the IF. But really, I'm not sure everybody knows what composability means. So you were kind of getting down to the definition of it. Can you just kind of explain that a little bit more?
Well, if you look back at the whole crypto area, right? Then one thing that was a problem was reusability of addresses, right? Our alias output solves that problem. You can have a fixed address, but you can still transfer ownership of that address to other people, right? That is a very simple concept, but it's very powerful. Same thing goes for the Foundry output. It's where tokens can be generated, can be created out of thin air, and where they can be destroyed again. And it's a single output type, right? And it can be combined, right? So you can, for example, have a Foundry on an alias, and thereby it's always on the same location, right? No matter who owns the Foundry. So you can transfer the ownership of the Foundry, but the address of the Foundry stays the same, so nobody will ever have to look for where did the Foundry go. And then we have now this huge DeFi system where NFTs started becoming a thing. So we took the essence of what is an NFT and we created a specific output for that, but with some properties, and I'm sure that we get to that point in the presentation, that are unlike any you've ever seen before, right? And you can combine those together again as well, right? Add to that.
Essentially, composability is being able to combine all these things together in whatever shape, form you want.
It's little Lego blocks that together can do much more than the original parts, right? It becomes more than the sum of the parts.
Right. All right. Thank you. That's exactly what I wanted.
And one other thing, we have 5 types now. The moment that we find out that there is something specific, a new specific usage that we haven't thought of, we simply add a 6th type. And it's completely transparent to the system, essentially, because this is literally a small script. We also very much looked at a very efficient script type of output. So it's like a miniature smart contract, but it does only one thing. It does it very well and very fast because it's built into the nodes, right? And if we want to add other like those, we can do that in a very simple way, and yet not impact the network too much performance-wise, right? Whereas the heavier stuff, you offload that to smart contracts on layer 2.
Gotcha. So really, new output types could be defined rather quickly and implemented rather quickly. If through the, as these are adopted, we see, oh, we missed one, right? You guys could really jump on it and maybe crank them out rather quickly.
Well, yes and no, because these output types have been discussed ad infinitum. Because every single one of them, right, as an entire team, we've been attacking and attacking and attacking them, because with everything in blockchain, it's not that simple usually. And if you start using them in combination, you have to be careful sometimes, right? So it needed to be very well-defined behavior, very essential, very simple, which allowed it to be analyzed properly for its properties in combination with others to see if we wouldn't open any gaps or anything in the tangle. So that's always a thing.
Unintended consequences.
Yeah.
Right.
So adding a new type is definitely on the table, and I'm sure we will be adding new types in the future, but they will be very well thought through. They will be vetted. We will probably set some security experts on it to help vet them, because every new type you add adds potential new attack factors if you are not careful.
Right. Makes sense. Okay, cool. David, let's go on.
Okay. Next is the
Unlock
NFT
blocks, maybe?
NFT blocks. Yep.
Yeah.
Totally.
This is the fun stuff.
All right. Another new thing which is down at the bottom is the unlock blocks. You might wonder why we have some stuff which is called alias unlock block or NFT unlock block. Well, I think we will also talk about it a little bit later, but for now, it should be enough to just say that with this tokenization update, it is not only possible to hold or control accounts on the IOTA network with private keys, but you can also control accounts on the IOTA network with NFTs. You can have an NFT which owns stuff and basically functions as a wallet. You can aggregate stuff. NFTs can own other NFTs, and you can sell the whole, the collection, or just parts. You can basically send money to an NFT as well. So it opens up a huge opportunity of use cases, I think.
So they basically become their own wallets. They become their own, like, I don't know,
so
network participants.
Yeah, NFTs might very well become network participants, or they can be used as, proxy wallets for a community.
Sentient.
Or a DAO.
Oh yeah, with DAOs, this is super exciting as well, right?
Yeah, exactly. So there's a lot of untapped potential here, which I'm sure we couldn't have thought about all the possible use cases, but that's why it's great to have such a lovely community, because I'm sure they will come up with really innovative use cases.
Yeah, I mean, the possibilities enabled through this are really so vast, and we can only make assumptions right now on what can be built, so it will be very interesting.
Yeah.
Okay, just a little bit, really short segment, but wow, a lot is packed into that. So we have NFTs that have their own address, which can own other NFTs, and I believe can actually pay and receive payment. So collections of NFTs can be owned by a single wallet or a single NFT. So these are the basic things to consider as we follow in onto the next part of the video here. But that alone is crazy powerful, because you have these blocks, you have composability, the ways that this could be implemented and how it could be implemented and used are just unlimited. So
you also have to. This not only they cannot only own other NFTs, they can also own other tokens.
Yeah, right.
It's not just NFT owns an NFT. An NFT can also own IOTA tokens or founded, a minted other token, or even Eric, I don't know. Is it no? Okay, it cannot. Can an NFT own a smart contract or control a smart contract?
No, the smart contract is always controlled by its committee, and with the distributed key to the alias output that is the smart contract address. So an NFT does not control a smart contract. Well, it could become the owner of a smart contract or another function inside the smart contract. So, for example, you could have an NFT that is the only NFT that can unlock certain functionality in a smart contract. Because
it's like
because
could be the owner. Could it be the owner of the alias address now?
Yeah. The amount of combinations you can do with this shit now is mind-boggling because you literally can have containers of containers of containers.
Yes.
Right. So let's say I'm an artist, right? And I'm very prolific. I create paintings and I create sculptures and well, let's keep it at two different types, right? So I have an NFT that actually is my own private ID, right? Where I can prove my ID, so that NFT probably holds my digital ID, so people can verify that it's owned by me, and that NFT owns the two collections, one of my paintings and one of my sculptures. They are both guaranteed to be mine, and nobody else can literally mine those because I created those collections, right, of NFTs. So it's a collection, and in each collection I create separate NFTs for every item that I created. So for every painting and for every sculpture. And then I can show that as a catalog. I could sell an entire collection of paintings as one group, but I can also sell separate items from a collection and just move them out to someone else.
Yeah.
And you will be able to confirm, people will be able to confirm that these are the original items from.
Yeah, you can always track from which collection they came, and the collection was owned by this artist, so you know it is from the artist.
Yes, the original work. You're not buying a copy.
Yeah.
And you could, I guess, also know who was a previous owner, because if Elvis Presley owned this piece of art, it is suddenly becoming worth more.
Yeah,
it'll be on the ledger.
Yep.
Right.
That can be done because you could trace the path that the NFT takes, and all the owners can be traced and always can be found back. And if there's a digital ID connected to where the NFT went, then you know who owns that thing now.
As long as they made themselves want to be known along the trail, right? Right.
You could have an anonymous.
Right. That's what I mean.
ID.
That's what I mean.
Like a Banksy, but you would know Banksy was Banksy just because of the other set of art that he created.
Well,
not that
that's
you
the
know
thing,
who exactly who it is. Yeah.
Yeah. Right.
Banksy creates things anonymously, but they are all connected to the Banksy account, and therefore you know that it's definitely a real Banksy item.
Yep.
And nobody still knows who Banksy is.
Yep. Exactly. I had another thought, and I don't know if it's possible, but essentially you could have an NFT whose account is connected with a smart contract that has, let's say, a revenue stream that comes in, whatever it ends up being. And that has a certain value. So if I said, you know what, I want to sell this though because I want to get some current value from it, I could sell that NFT to someone else, and then that revenue stream would go to the other person I sold it to without ever having to, say, okay, well, let's transfer because the account is associated with that NFT. That's a practical use case, right, Eric?
Yeah, Yeah, you could set the alias output for the NFT, and it can be controlled by a different account, and you can transfer the ownership of that alias output to someone else, and then that person becomes the owner of that NFT.
Yep. Yeah, that's extremely powerful too.
Yeah.
What also kind of interesting, I think, what imagine like you want to buy art when the artist is young and kind of needs the money and all that kind of stuff, right? But then 20 years later, that artist is famous, and you sell it at a huge profit. Yeah. What would be awesome is if you could, of course, put into the contract that this artist also gets a cut out of every future sale. Yeah.
So royalties.
Yep.
Yeah, exactly. Yeah. And likewise, also if you, let's say, promote your art through a certain gallery, or you have a certain owner like Elvis and so on, right, they could also become valuable people in the provenance of the art. Yeah. Because they will increase the value. So it's very interesting how you can create economic incentives in such a model. Yeah.
Oh yeah, there's an implied.
This is literally
value
just
creation. Yeah.
Yeah, it's just scratching the top of what's possible, because once you start really diving in, right, and you understand what the possibilities are of those combinatorial blocks, inputs and output, right, there is such a huge combination of possibilities there.
Yeah.
Right. We will have years to explore them. Seriously.
Yeah. It's absolutely mind-boggling. Go ahead.
So Eric,
I'm sorry.
is it the case? Yeah, thanks. This is Chris. So Eric, can you clarify for me? So is this something that is or is not doable in Ethereum or Hyperledger or others today?
Not without smart contracts on Ethereum. You could create the functionality, of course, but you don't have the building blocks like this available at such a low level.
Okay.
None of the output types are there.
You see what happens the moment there are 100 different tokens all running on top of Ethereum. It brings it to its knees very quickly.
Yeah. So then what's happening here? So the point being that this happens without a smart contract. Is that right?
Yeah,
exactly.
And in parallel, and with not onerous fees, because that's not built in at the level 1, where it is with Ethereum and the other coins. So that's those are the two, I think, key distinguishing characteristics. Parallel.
Well, I'll also add the third one, which is, or maybe one. I mean, it's that it's on L1, and it's the secure layer, right? It's the performant layer, and it's secure, and it's feeless. So if you're going to try to do the same thing on Ethereum, you're not going to have speed. You're gonna go. You may have to leave the chain. Break the security model, or become less secure, I should say, and not be as performant, and incur fees.
And incur large fees.
Yeah. I'm thinking with this, we can boil the ocean. That's what guys used to tell me, the providers that from Ethereum and Hyperledger, they would say, Chris, because I'm like, they would come up with a very, very narrow type of application. And that's what they would accuse me of. They say, Chris, you're trying to boil the ocean. And it's like, well, here you go. IOTA's just doing it. It's incredible.
I do believe you're right. I do.
Yeah, right. I mean, it's crazy. I mean, gee whiz.
I do.
Good job. Way to go.
All right, let's move on to. It's so funny, you guys. When Ben and I were trying to figure out the snippets, we had so many of them. We kind of said, we could just play this whole video. We have so many.
We're kind of doing that. We're almost in line here with some of this stuff.
I know. Well, let's go.
We're going to do the unlock block, which is the Russian doll nesting, which Craig has coined here.
Yeah. All right, let's skip a little bit because these are just pure validation rules. I don't think everybody's here for the tech, or at least not for this specification level thingy.
Okay. 1 second.
Don lost it. Don lost it here.
I think the broadcasting software sometimes hangs.
Happens to the best of us.
Maybe like I'm just trying to wrap my head around the unlock block stuff because I don't fully get that right now. What does that mean exactly, that you have an unlock block, and what does it change?
All right, so an unlock block is basically, imagine transactions and inputs and outputs of a transaction as boxes. So each box holds IOTA funds. So if I want to spend this IOTA, I have to unlock the block, unlock the box. So how does the protocol know if I am allowed to unlock that box or not? Well, I have to provide a valid signature, or at least somehow prove that indeed I'm the owner of that box. And previously, or at least what is currently out there in the mainnet, the only way for you to do that is to say, hey, here is my digital signature. This verifies that I own this box. But with the new tokenization framework, what you can do is you can say, hey, this box is owned by an address, but that address is not controlled by cryptographic private keys. That address actually is controlled by whoever controls that other address.
Mm-hmm.
So
fascinating.
So basically what happens is you can have global addresses in the Tango. Behind those global addresses, you can rotate or shift your keys, so you don't have to reuse any keys more than once. And bam, you can have a wallet on layer one with a permanent address, but you never reveal or you never sign anything with the same key twice. That's the importance of this whole unlock block concept.
Yeah, I mean, like you can really see that there was a lot of thought went into this entire RFC and a lot of experience and feedback also from the current crypto ecosystem.
Okay. All right. So before we start, the Russian nested dolls, that is Ben's. I got to give him props for that because I had talked to him about it and I called I think I called called them nested, but he actually
okay, sorry.
coined that. No,
it's going in the Wikipedia.
There you go.
Is he on that?
Yeah. Got to give props to the guys who did it. So, yeah, powerful stuff, right? Powerful stuff. It's kind of we kind of did kind of already cover this in a way, I think, in a previous conversation.
I think, but it's kind of like abstracting addresses where you now link them together in a way that seems simple, but I think that's also going to be another place where we're going to see unfound different ways we can use that to simplify what we do. Because now that you've abstracted addresses away and you can say, you know what, I can have this other address controlled by this one address, then things become, we're able to have consistency where we want it, but allow change where we need it. And I think that's very powerful.
I think it might even also be make things sometimes kind of user friendly. Yeah. So if you are if you have like the possibility to control actions of other addresses in the tangles, actually initiate transactions without the let's say the hustle and the burden that you have to go with signatures and wallet stuff. So kind of you have a master controller that initiates actions on other addresses only by being referenced in those unlock blocks. So you can actually kind of, I think I envision it, you can execute chains of actions against there in the tangle that kind of be just initiated once, but then you create this Lego blocks of functionalities, and you will not need to all the time provide a new signature, provide a new private key, and stuff like this. So I think that can make some applications really more user friendly if you sketch the things together in like chains of actions.
Interesting.
I was thinking of it as kind of like pass by value versus pass by reference in traditional programming.
Yep, I can see that definitely.
And this just kind of builds upon what Eric was talking about. I mean, he basically spoke about this, I think, previously. So let's go on to the next one.
Okay.
Because we're building on this.
Here. Okay, so the next is native assets first class citizens at 30.
There we go.
30.
So for starters, we want to make, as you said, native tokens a first class citizen in the IOTA network. And the best way to do that is to directly add support to all output types. And we do this by basically adding new fields, optional fields, to all outputs, which we call native tokens. So that little table there summarizes that, for example, in an output, you can have a lot of native tokens which have each a token ID, so an identifier, and they have an amount. So the token ID is just the globally unique identifier of a token. So yeah, I just wanted to say here that we will discuss later how it is generated, but it's enough for you to know that there can never be two tokens with the same token IDs inside the ledger. So it cannot happen that you create Domcoin and I create Levicoin and they both have the same identifier. This has like a 0.000 many more 0.0001% chance. Technically, not gonna happen.
Right.
So
Okay, so new option fields for native tokens and unique identifiers that can't be duplicated. That obviously I think rolls into NFTs. And
right. Other tokens that are created there too.
Right.
And
any digital asset really. Right. So yeah, well, I think we'll see the power of that in the next segment. So let's kind of roll.
Okay. All right. I'll just continue from here then.
Yeah. So moving forward, we added a new suite of features which we call optional output blocks. So these have nothing to do with the blocks in blockchain. This is just how we named it. Imagine it as basically like Lego building blocks. So you can take these building blocks and you can build your own output or customize your own output. You can build whatever you want. And if you, depending on what building blocks you put into an output, its functionality is extended. So for example, the first one, what we see here as a sender block, that is actually something which naturally were born out of the needs for smart contracts. So imagine that you send a request to a smart contract with a transaction on like an on-ledger request on the IOTA network. How does the smart contract know who sent this request? Like all they see is an output was created to my address with such a data and commands and whatever, but who sent it? Well, the layer 2 nodes would need to examine how the transaction looks like and try to infer, okay, who could have been the sender? But instead, you can just put a Lego-like building block, sender block into the output. And then the protocol takes care of validating that whoever claims to be the sender actually did sign the transaction. So you don't really have to care about it anymore, and you can be sure that this request must have been sent by someone who approved that transaction. So this is an absolute necessity for smart contract support. Also, it is used for the tokenization framework, which I will talk about a little.
Okay.
Well, I don't know. I mean, that's self-explanatory there, I think, but it's just building blocks, I think, as we kind of go forward. Anybody else have any? And we're just adding on the new types of Legos that we can add to this, right? So let's crank forward.
Okay. All right. So next one is minting NFTs on layer 1.
Okay.
I'll just
a little bit down there. So yeah, just an interesting note there. As you can see, these address types and stuff. So usually, since Chrysalis, our addresses look like IOTA 1Q something most of the time. So what we did is that to help users basically check who they are sending funds to, we designed the system in a way that if you create addresses for example, NFTs, then the starting character will be Z. And then users can already see, okay, I'm sending money to an NFT, or I'm sending money to a smart contract chain, or whatever.
Oh, that's interesting.
That's just some usability aspect which we try to take into mind. Yeah, so there is an issuer block is there, which will be important for NFTs. So basically imagine that you mint an NFT on layer 1 and you put there an issuer, basically a public key. And then basically for the lifetime of that NFT, this issuer block is there as a stamp on the NFT that this NFT was created by this particular artist and no one can remove it. So this is proof of authenticity, sorry.
Authenticity, yeah.
hard to pronounce.
Yeah.
But this is like a proof of authenticity which gives you the guarantees that this NFT is not fake. You can verify yourself that this NFT indeed was created by people, for example.
Right.
And no one can cheat you.
I mean, this is super important, right? So basically, if you mint an NFT on the layer 1, and this NFT gets transferred to another person, like let's say it gets traded, that other person can actually fully verify the provenance. Right? It can verify, hey, this NFT was actually minted by this artist, and this can never be changed, right?
Yeah, this can never be changed.
That's huge. I mean, that's huge, yeah.
Changing it would be the same level of complication as basically changing anything or hacking the IOTA network. So I highly doubt it's possible.
Yeah, I mean, this is one of the big problems today, right? Where we have those centralized NFT marketplace actually giving you like some kind of confidence score if it's real or if it's not real.
Yeah, I mean, if they have history on it, then it might be real. You can never tell. With this, you can absolutely tell for sure.
Okay, right there is that is the secret sauce. That is a bomb was dropped right there. For people that have been in the NFT space, for all of OpenSea or right, and all these NFT marketplaces, they're always trying to establish that their NFTs are not just JPEGs that are copied, all over the place and resold, right? And they try to get around it with trying to prove the history of ownership and things like that. It seems to me like what we've just done is we've delivered the goods right here. We have a demonstrable way to assure anybody who creates and sells and purchases a way for them to verify that this is the real deal, to verify the chain of command, to basically know everything they want to know about the authenticity of an item. And I don't believe anybody else out there is doing this. So, big deal.
I think I heard someone else was going to say something on the topic.
Ben said it's huge. It is huge. Anybody else? Yeah. Cool.
I mean, it's linking it in with the IOTA network, and there might be other weaker links in the chain, but as far as the establishing ownership back, this is creating something as solid as it can be, because it's essentially within the IOTA ledger.
To me, it's an NFT maker's dream.
Yep.
Proof provenance.
Mm-hmm.
Right.
Exactly.
We are working on we're working on a platform right now in where not for the stage that we are at right now, it's gonna issue the NFTs.
Mm-hmm.
But the next step after we finish the smart contract and the integration is to go in that direction. So if I'm understanding what you're discussing right now, the way to certify the procedence of an NFT be through a DID that signs on the NFT, or that's built in the NFT itself?
It's built into the NFT itself.
Yeah.
The way I understand it.
There's an issuer block, and then that issuer block is part of the NFT. And maybe there's even a more detailed example that either Eric or Phylo could give on that, but it's an essential property of that. Well, I think from an IOTA standpoint, it's an optional, but for an NFT, I think it's mandatory.
It's part of the metadata, right? I think, or the.
Yeah, it's part of it. It's immutable written in the NFT. You can never change this issuer block, even if it gets transferred. So
right.
this piece of information will always be part of the NFT. If you kind of would try to remove it, I think the NFT is it's not possible. You cannot remove this information out of that NFT. And so when you are creating this NFT, you actually put your address, either the address that you control, or like the DID that you are controlling in, and so it's like never possible to change the origin of this creation of the entity that created or minted this NFT.
And I also think the question was also, is it just within the NFT, or but I wasn't sure if the person was asked if DID was involved. I don't think DID needs to be involved with this, but there's also the identifier, which I don't know if that's involved with this or not. Because I'm learning this right now with you guys. So.
I'm actually not sure what you can use as this issuer.
I think if I'm looking here, it says it can be an ED 2551 address, an alias address, or an NFT address.
Oh, there you go.
So either one of those three.
Anything where you can provide a public and a private key pair for the date, you can actually prove it with your signature that you own it. And also, if somebody want to recheck with you, let's say you are Beeble and somebody says, I don't believe that this is your ID, then, I mean, Beeble could actually offer his public key on his website and say, okay, if you want to check if I'm the owner of the piece of art that you are buying, check it against my public key here, and then it's proven that it's the ownership is clearly proven then.
Yeah.
And here we have again the expandability of things, right? You have the three different issuers there, but it's easy to add other kinds of IDs, like a digital ID, as the issuer, and then you have a way of verifying that person actually exists, or who it is, or what not, right? So the ownership is very flexible in that regard. The ownership component of this whole tokenization framework. It's literally anything can own it, and all you need to do is show that you have the keys. And if it's a DID, then okay, then you show you have the keys to the DID, and then you own it.
Right. So if you add a DID to it, you could make that work, and there might be use cases why you would want to do that. Like for example, you might want to be an anonymous buyer, and that would help you do that.
Even think further, yeah. If you look in governance use cases and things, yeah. So if you get a document as an NFT with that is kind of containing the issuing of the state, of like a U.S. state, you could have a national ID as an NFT that is issued by the U.S. government, and it's proven issued by the U.S. government because the U.S. government writes its issuing ID into into the NFT, and you can have it as a national ID or as a driving license or whatever. Yeah,
yeah, that would work really well actually.
And it's unforgettable. It's like nobody can create fake IDs or fake things with this, because if you are not able to prove that you are the signer of this ID that issued it, then it's clearly a fake thing. Yeah, it would be super easy to check those things.
So, Gianfranco here, what about these NFT as a document with verifiable credentials? Because one of the things for verifiable credentials is that you issue them off Tangle, and then you create a Tangle certification or verifiable presentation of the credential.
Well, are you speaking to the document needs to be stored off Tangle because of size and that thing? And so you would basically have a hash that would
of the document. Yeah.
Of the document, right? Okay. That would
I don't know. Jaco. I'm not so deep into the DID thing. I think the verifiable credential is is it stored off Tangle, or it's still a data transaction, yeah? But it's not.
Yeah,
the signing is on the Tangle, but the VC is off the Tangle.
Yeah.
Right.
And I think
don't want a document or something on the Tangle for security reasons.
Yeah, and it's simply an operation of hashing the document with the operations of the signatures and everything else in the way that verifies that the only, the hash of the document along with your signatures matches the official hash with the signatures of the state, and you say, okay, yes, they both match, so we know that the authenticity is verified.
And then the cool thing is now that you can actually, with the new dust protection thing that is coming in place, you could do something like this, that you have forever stored this VC of the United States driving license issuing. You can have this forever stored in the ledger. Yeah, it's not something that is a pure data message anymore. You can just include it on an UTXO forever in the Tangle, and as long as you have the dust protection deposited on it, you can store this information forever in the Tangle, and you will forever be able to just query it in the Tangle directly without the need of having this off-chain functionality anymore.
Also, somewhere in this video, they talk about the size, and Dave and I were talking about this earlier, but NFTs and whatever can be stored in a smart contract for an NFT. The size is like 32 KB, I think it was, Dave, we decided on, right around there?
At the most, but there's some overhead within it, so it's going to be less than 32K, and it depends on the other metadata in the message that determines that, I think.
But there are small, like we were just talking with an artist, a designer earlier today, and he basically was saying a lot of the Nintendo games, a lot of their images and so forth, characters and so forth, are small enough that they could actually be stored as NFTs and fit within that space, and you don't ever have to worry about them being pruned or anything, because they basically will sit in a smart contract, and the storage is sufficient enough for that kind of stuff. So people will start doing some creative stuff like with that, just because it's free storage. You don't have to worry about permanents or anything of that nature.
So we're talking now about NFTs, and you just had an example here of how I can actually store close to 32 kilobytes. I guess this whole concept of an NFT I could also use to actually just basically secure and move a data set, correct?
You could.
Yeah, it depends on how you would accomplish that, but yeah, I mean, depends on if it'd be inefficient to do it in 32K chunks, depending on how big it is, but yeah.
Well, normally you would secure your data set by securing the hash.
Yes.
Right.
Right. So if I want to prove that I have a certain document at a certain time, I hash my document and then I put that as an NFT on the Tangle, and then the date of issuing and everything is known. So I can prove that I owned that specific document at that time because I'm the only one that can create a document with that specific hash.
And then, one problem is always if I make data accessible to third parties, yeah, I want to make sure that they don't pass it on to other entities, right? And let's say personal data, advertising kind of stuff, right? So if I wanted to create a data set that I now sell to one individual company, for example, could this be a way to ensure that they don't, once they have the data, they sell it to somebody else?
I don't know how you would control the flow after that. Yeah, see it.
I guess the only way would be if you controlled actually the access to the data. If the data was stored still in some whatever offline storage that you control, and you would use the NFT to carry the access key.
Yeah, it would have to be some form of access control that would then be accompanied by some other solution to provide.
So yeah, in essence, like a two-factor.
This is where an alias address comes in.
Yeah.
Right?
Okay.
You have an alias address where that thing is connected to, and the ownership is defined by the address that controls the alias address, and that ownership can be passed to someone else.
Okay.
But if you want to avoid that the ownership is passed, do we have something like a non-transferable token functionality? So you could say I grant you access through this NFT, but you will never be able to. The only thing that you can do is you transfer it back to me, but you will never be able to transfer it to somebody else. So you could have this fallback address, like if there's a. You could also define a time. You could maybe sell access to something for a certain amount of time. You make like a time lock on it for 6 months, and then afterward it gets transferred back to the issuer, but it's not possible for the one that received those NFT to transfer it to anybody else. And you can create like this. You could create a time locked or a time restricted access to, like you said, a set of data or something like this.
Or actually an access key to something.
Yeah.
Right.
Am I on the right path here, Eric, or is this out of
I would have to think about it. I was thinking earlier that you can use this system, for example, to secure access to a website or something, and the access to the website is granted to the person who transfers a token on the address, the alias address that belongs to that website, right? So that's the only person that can do that. If you want more complex behavior, like it needs to be going back to the original owner at some point, I don't know. That's.
I think there's
I myself haven't dived in all the possibilities of all the inputs and outputs and unlock methods. So it could be that that is.
Yeah, I think
you have the return output, I believe. So
yeah, you have to return output, and you can define this like it's gonna be definitely returned to the issuer block or to the defined issuer.
I know you can do that. I just don't know.
There's another segment that's a time lock tokens. I wonder if we want to watch that and see if that.
Yeah, I think we need to like go down the path here, but I'm still questioning this.
Let me play that.
Go.
That's a few minutes, and then we can see if that's there. That may be not a optimal solution because locking it for such a long time may be not the right path. But let's see this.
which actually is just a rule that until the time which specified in here passes, no one is allowed to move these funds. So it's great for example, token vesting schemes. When you say, hey, someone just created their own tokens and they want to ensure the community that there is no rug pull. So what they say is, well, for 1 year, I cannot move my tokens. And then you know for sure that the protocol doesn't allow anyone to unlock it. A more fascinating use case of this is if you use these time locks for smart contract requests, then you can basically time your requests. I can right now put a request to a smart contract chain, which I know for sure will only be executed tomorrow this time. I can time it, and the network ensures that no one can violate it. The next one, which is time based, is called expiration. If you scroll a little bit down.
That's really fascinating, by the way. Like I never thought about these use cases and these possibilities actually, that you could have these conditional transactions where you already send it today and it only gets executed tomorrow.
Yeah, or you can give allowances to your kids, and you just say, hey kids, take my IOTAs, but I put a time lock on it, so you can only have 100 IOTA per week.
That's amazing.
Yeah, so there's the expiration blocks there, which is similar in a sense to a time lock, but the big difference is that basically expiration means that you specify a deadline, an expiration deadline, and if the recipient does not spend or consume these funds before the deadline, then you as the sender gets it back. So why is it great? I mean, it again comes, the basic idea came from how you interact with smart contracts. So if I'm sending a request to a smart contract chain, I want to be sure that my request is processed. And if my request is not processed, well, I want to take back my money. So what I do is I send a request and I set an expiration day and say, hey, smart contract, well, you have 5 hours to execute my command. If you fail to do so in 5 hours, I just take back everything. I don't pay you nothing.
So I think those two concepts are also extremely powerful, which kind of sounds redundant at this point, but time locked and expiry. And I was looking at the time lock there, and you have a milestone and in the Unix time, I think, to define that. So I think there's a potential where you could use those to solve that problem and say, you know what, I don't want you to spend these NFTs, and you set a milestone that, well, I don't know if actually that milestone may be short term, but from a time scale, I don't know how far in advance you could set that, but if it's over a couple hundred years, that might be reasonable.
Yeah, I mean, there's different things, but when you that you can do to manage times. I mean, some of this is akin to what's already happening in the trading world, right? Like I can actually do a good to cancel order, right, for 60 days, 90 days, or stuff like that. All types of time-based programs that exist when you're trading. This is just kind of the same type of thinking. But I don't know, when you get back to talking about access control, I don't know that we found a way to prohibit that being shown or sent to other people.
Well, I think,
or you also run into cases where
time
you
lock,
might.
Isn't the time lock going to say, Mr. Node, you can't process a transaction unless this time has passed? So, I mean, the only question is how long in the future would be a reasonable time. But
okay. So if let's say I send it to I pick it up, it's on my iPhone, but now I want to get it onto my Mac. What happens there?
I think you would have to use the same seed or.
I mean, there's a lot of things to think through. Yeah. Okay. All right.
There's one question that comes up here, which is kind of I don't know exactly how I think about this now, but is it a correct statement that I can think of any proprietary logic within my smart contract itself, as long as I abide to certain input and output types that then trigger the updates to the tangle?
I think that's absolutely correct.
Yeah, exactly.
Yep.
Yep, you nailed it. That's
because the node's not gonna do what it can't do. It has to abide within the RFC specifications and validation for that. So even if smart contract says, "Hey, do this," the node may say, "Nope, sorry, not gonna do that."
Yeah. All right, let's go into the next one. We're getting to about. I mean, we got a lot to go through, guys, but I mean, there's some juicy things here left. So
okay, so I think we left off on let's see here. I think it was Russian dolls, native assets. We did optional output blocks. I think we got to NFT, mint NFT on layer 1. Did we do that one?
I don't think so.
Okay, let's go through that and see that.
Take into mind. Yeah, so there is an issuer block is there, which will be important for NFTs. So basically imagine that you mint an NFT on layer 1 and you put there an issuer.
Okay, I think we did this one.
Okay, yeah, all right.
We did this one. Okay, conditionals, layer 2 swaps and offers. Okay, so that's the next one here.
Put conditions on the funds which you are sending, but it also makes it possible to implement directly layer 1 swaps. So imagine that I send you 5 Levy coins, and then I say, "Hey Dom, take my 5 Levy coins, but if you take it, then send me back 100 IOTA. If you claim it, then it's yours, and I have the 100 IOTA back. If you don't, then I will take my 5 Levy coins back." And this is ensured and automatically processed by the protocol. So I can give you an offer basically,
right,
for whatever I feel like. That's one use case of it. Another use case has to do something with the dust protection, which is the other RFC. So we will talk extensively about it. In short, it's actually there to make microtransactions possible with the deposit scheme.
Yep.
This gives guarantees that the recipient can only consume funds or outputs which they receive if they follow the rules defined by the sender. That's in simple terms, that's it.
Yeah, no, it's really fascinating. I think the dust protection will probably have to do a separate show just on that because it's another big one. But these return blocks, so basically I could define a transaction that says if you don't spend these tokens within the next, I don't know, 24 hours, they will be returned back to me, right? So it's like you can even think about them like gift cards of sort, right? So you can only be redeemed within the next 24 hours or else it expires, so to say.
Yes, exactly. So, I mean, usually these more complex use cases, like you mentioned, you will use another block as well, which is called expiration or time locks, which we'll talk about shortly. Yeah. So when you combine these blocks like Lego building blocks, then you can achieve such complicated use cases as you mentioned, for example. So you can say that, well, you have 2 days to claim it, unless, I mean, if you don't claim it, then just get it back.
Right.
It's your bad. Okay, so we added another block called time lock block.
Okay, so we'll stop there.
Did anybody actually realize what this is? Actually, we will have the possibility to have a decentralized peer-to-peer token exchange on the tank without anything. You don't even you maybe need a website, but actually if you see if you know there is an address that has a certain amount of tokens sitting on it, you can actually make an offer to this address and says, hey, I want this 25 Gman tokens on your address, and I'm gonna offer you 100 IOTAs for it. And you have 1 day to accept the offer. And actually, this is like local bitcoins or something. This is like a peer-to-peer,
It is with conditional with conditional attributes that where you can lock in the assurance that you get your money back if something goes wrong.
It automatically happens. You make an offer. You say, okay, you will get 100 IOTAs if you accept my offer, and then automatically your 25 Gman coins gonna be transferred to me, and my 100 IOTAs gonna be transferred to you. And that's actually, did I understand it correctly, Eric?
Well, it goes a step beyond that. This isn't. You don't need a website for this. This will become basic functionality in your wallet.
Yes, you just search. Let's say you really maybe you find you look in the Explorer or somewhere for an address that holds, or maybe even the wallet shows it to you. These are the addresses that hold Eric Hop coins, and so I can send out offers to people that hold those coins, and if there is somebody that says, okay, that's a nice offer, I'll accept it, and then I have made an automatic token swap between me and some other address, and token's gonna get exchanged, and it's kind of a
and the only thing involved is a wallet on either side. There's nothing else necessary. You will see certain functionality, just like your bank software offers you all kinds of things, right? Apart from only transferring money from A to B, you have automatic payments, right? Every week, pay X to this address or something like that. All those basic functionalities that are often used, you will see them start popping up in the wallet.
Yeah, timed payments, all those kinds of things. Automatic deposits, all kinds of things can happen. So I'm just curious, how in that case, how would, and this is always, I haven't looked at it in years, the peer-to-peer stuff. How do you advertise? Is it a subscription model? How do you let the world know that?
You could maybe in the end maybe there will be a kind of a website where you can make offers like this and say, okay, this is my address.
Or I'm open. Yeah, right. Yeah.
If you make me an offer that suits me, I'm willing to sell my Eric Hop tokens. But you could even do it without website. If you search the Tangle and you find an address that owns those tokens, you can directly make with your wallet an offer, and if the other one opens its wallet and sees, okay, there's an offer, there's like there's a request of a swap, of a token swap, I can accept it or not, so I have like 24 hours.
No, and the smart contracts would just be able to handle that and make sure that you get payment and everything.
You don't need a smart contract. It happens on level 1. It's without smart contract.
All right, level 1.
You know what I just realized is that with all this utility, especially if you want to directly be able to search on the Tangle, it becomes more and more of an incentive to run your own node.
Mm-hmm.
Yes.
Yep.
You can do all these queries only just with your own node, with your
And if you actually do it all on layer 1, then because I just had, of course, the idea, hey, look, of course you can run auctions and sort stuff and all of these kind of things, right? Now, because you have it on layer 1, you have a more liquid marketplace for it, right?
Yes.
Because everybody sees it, and it's not just somebody who is in the smart contract or on some dApp,
Yeah, and also it makes things like it's so great because it takes these basic functionalities that other coins always need smart contracts and validators and miners and things for this, which it's like not super complicated logic there. And so you keep the space also free for smart contracts to do real fancy computational stuff, like real programming logic that is needed in a level 2 solution. Yeah, but these things like the little token swap between token A and token B, this is like in other protocols, you will need to pay a miner for that. You will need to pay a validator for that. You will pay transaction fees and stuff like this. You will congest the blockchain of the smart contracts with it. And these are simple things that are just going to be handled on the Tangle, easy peasy, without fees, quick, bang, happened. Yeah.
And one question that I have, which I don't think we can answer today here, but I wonder always when I think about these scripts, and think about, like, I'm from SAP, right? That's like how I started in software, so not the most modular and small footprint kind of logic, yeah. But I wonder, like, how much logic in that sense can you actually put into such a script, and how quickly do you run out of steam on that front?
Well, you definitely want to keep that under control, right? Because the thing is with these little scripts is that just as with Ethereum having to run each smart contract, essentially everybody needs to be able to verify these little scripts as well. So they need to run them. And that's why we try to keep it as minimal as possible and only provide things that make a very good utility case to add to it.
Okay.
Okay, guys, we could literally go on for longer time. It's 2 hours. I what I think would be kind of fun. Did we talk about foundries? Dave, can we go to let's kind of jump ahead and go to 101.
Okay.
Yeah, the foundries is something we really. This might be the final nail in the coffin for today.
Coup de grace. Such an amazing,
Okay, here we go.
Such an amazing thing.
One which I want to mention with these aliases is you see something which is a foundry counter there. So why is it there? Why do we count foundries in smart contract chains? And that's exactly because of the trustless bridge mechanism which we want to introduce. It's because we want smart contract chains to be as powerful as they want by giving them the opportunity to act as issuers of native tokens. So this is the foundation for the asset wrapping logic. A smart contract can create foundries, which it fully controls. So it can create these foundries, and it can use these foundries to constantly change layer 2 and layer 1 assets, basically mint and burn them as the smart contract regulates it. So this is why we don't need additional trusted bridges in this whole architecture, because we made it so that smart contracts are also first-class citizens in IOTA, and they can act as controllers of foundries.
Yeah. So this is the secret sauce.
Yeah, this is the secret sauce.
I mean,
I just shared the
amazing.
recipe, so it's not secret anymore.
But it makes a ton of sense, right? Because you want to have smart contracts that are able to mint tokens natively. It's not just people that should do it. It should happen autonomously with smart contracts. And the beauty is exactly what you said, this trustless and feeless bridging between smart contracts. And no other network has that today, right? Such an architecture.
Not really.
Yeah.
Okay, so now we introduced foundries. The next one, I guess, will be the foundry output itself.
Yeah.
So yeah, a little bit further down. The foundry output there.
Oh, that's here.
Yeah, you nearly skipped it. So what about foundry output? So foundries are the entities in our ledger which regulate the minting and burning of native tokens. I would like to point it out here that we completely transitioned from the old colored IOTA concept into this foundry-based concept. So a foundry does not have to have, does not convert IOTA tokens into assets. What it does is it basically mints them out of thin air. anybody can inject their own tokens into the IOTA ledger. You don't have to buy like several mega IOTA to mint several million tokens. All you have to do is create one Foundry output, load it with a little bit of IOTAs to compensate for the extra space you take up in the ledger, which will be negligible, most likely a couple MIs. And then you can start minting and burning tokens, basically creating them out of thin air and burning them into oblivion.
Yeah. And here you can then basically have like elastic supply, right? It's not that you have a strict definition of, hey, you only have 1 million tokens, it's capped.
Well, it depends on what you want. So each foundry has a so-called token scheme. Right now in the specs, there is only one token scheme. It's the most basic, simple one, which basically says, well, you can choose the maximum supply, and then, like circulating supply can never be greater than the maximum, but besides, you have no restrictions.
Yeah.
In the future, we want to add some stuff like inflationary or deflationary token schemes, controlling the burn and minting flow. So you can actually implement new types of supply control rules, so to speak.
Okay, I'll stop it there.
Okay. Wow, right? A lot to unpack there. So, I mean, Phylo, what do we got? We got foundries act as issuers, right, of tokens or of NFTs, right?
Yep.
They can mint and they can burn.
Mm-hmm.
There's no trusted bridges required.
Nothing.
You
really have to see that the tangle is getting kind of a monster. Yeah. So as soon as this is, you are creating we're creating a whole new world of tokens just on the tangle. And then you have another universe of tokens and possibilities on level 2. Yeah, so it's kind of this,
it's a really interesting way when they're talking about inflationary and deflationary. You can literally use this technique to get around concerns about not having enough IOTA tokens.
Well, you can just double the supply in just for your own coins. Yeah?
Right.
You just create
exactly.
2.7 trillion PI of Greg coins residing on the tangle. Yeah, they have the same functionalities and the same
security, the same model, everything.
Everything the same. Yeah, you just create them. They're not identified as original native IOTAs. They have a different identifier, but they have the utility and the functionality.
Where I'm thinking is like if we ever, there are discussions like, do we have enough tokens out there for specific use cases, right? And people talk about what would we do there. And this could be a way for us to address those. It's just really interesting to think about.
Wow. Yeah, that discussion is over.
Yeah.
And I know that for sure because I was the one constantly rattling that cage because I was worried about the fact that we didn't have enough tokens to run the world economy, essentially.
Oh my gosh, I can't believe that I thought something the same as Eric Hop did. You made my evening. My day has been made. Okay. Right. Wow.
So, can I ask, so can these be minted only on layer 2?
No.
Okay.
Anybody can use this foundry, but it's specifically so that any entity can do it, and that means that smart contract can do it, and that's the important part, right? You want, for example, if you're starting to think about the governance of these tokens or the scheme of issuing or whatnot, right? You can go way more complex than a simple this is the cap, or there will never be this more than this amount of tokens. So you will pretty soon. Well, there are use cases that are simple and straightforward, right? And then you can use the level 1 functionality. But the moment it gets more complex, then you get into the domain of the smart contracts, and therefore the smart contracts should be able to do that foundry stuff.
Well, it's beautiful just from I'm thinking a manufacturing standpoint, right? From like automotives, they build a car, and where they stamp that VIN, I think it's what, 17 characters in the US?
Yep.
The vehicle ID number. That is kind of like within, I know for a fact, having come in from the industry, that whatever machine it is that does that is kept under very close guard. I mean, that never can get out of anyone's, purview, or whoever's, responsible.
Right.
And just think about all the things that are serialized. It's not just that, what, computers, phones, whatever. And so what this does is just frees up the manufacturer to have really, it seems, complete confidence that that if they create something, they know it's theirs, and the buyer knows it's theirs, and just throughout the whole supply chain, you're going to know exactly where it came from. So
And you can track it, right? So this is
yeah,
the whole supply chain digital twin concept as well.
beautiful.
Yeah.
Wow.
I think what it
Yes, which
also
Alex just woke up. So I know
allows
that.
is for you to have different monetizations that aren't tied to IOTA, even though they're based and controlled in the same ledger. You create your own money supply, you create your own tokens, and they can be whatever you want them to be, the supply, the economics, and everything. So you can have multiple economies running within the tangle, essentially.
Airlines frequent flyer miles.
Oh yeah.
Yeah.
Whatever.
Forgeries, right? You're talking about forgeries, right? Amazon has this problem with forgeries, right? Bam, this would solve it.
Yep.
Well, one thing is also interesting now about
concert tickets.
Yeah.
Yeah.
So is it actually if you can create a token for pretty much every use case you have,
yes,
then the coin becomes really the thing that runs the core infrastructure, and it doesn't get burned or inflated, but it's just the fuel that changes hands, but is really the thing that operates the infrastructure itself, upon which then these different tokens create utility.
I think that's one use case.
General, yeah.
But I think there's many others. I mean, if you look at, you need IOTA to tie to certain accounts for the dust protection, and then there's just native IOTA exchange. It has a certain value in itself. But I think this provides layer upon layer upon layer of other utilities for IOTA that will only increase its importance, which will increase its value. At least that's how I see it.
Yeah, because why I'm saying that, because also in the Stammtisch on Mondays, one thing that is being discussed is since the Tangle is supposed to become this economic infrastructure to run the world economy, the world economy, in my mind, of course, that will have to change, is running on an inflationary model, right?
Mm-hmm.
So we assume today that a certain level of inflation is useful for the economy and for driving growth. Yeah. Mm-hmm. So the question becomes, hey, should maybe the fixed supply of IOTA be reconsidered? I actually think that our economy as it is fucked up. Yeah. So we have to actually come up with a different model that is not based on growth. Yeah. But that's where I was coming from, also to say, look, the coin could run this infrastructure itself, yeah, and from that point of view, yeah, I guess, yeah, I don't know the answer, yeah, but that's where I was coming from, saying that the IOTA coin runs the core infrastructure upon which these other tokens live now.
I don't know if the way you're phrasing it is right. The IOTA token, well, maybe it is. I have to think about that. Interesting. Yeah.
Well, the coin itself is necessary, right?
Yeah,
because
for sure.
you are going to need an address where you can place tokens, and you probably want dust protection there. So you need to have a minimum amount of IOTAs on any address that you use, essentially. And this is driving the adoption of the IOTA token itself. So you can create all kinds of tokens on top of it, but they are just like on Ethereum, you will need to be able to use gas. So with IOTA, you need IOTAs to be able to put them on the Tangle, right? You're paying for the storage of the token essentially by, well, not exactly staking, but holding
Positing.
a number of IOTAs. Yeah, it's like it's a deposit literally. The moment you no longer use that address, you take them out and they're still yours.
Mm-hmm.
Right? It's like when you pay 25 cents for a bottle and then return the bottle, you get your 25 cents back.
Right.
And don't forget that even though the number of IOTAs may not grow, it's still a humongous amount. And if it's mostly being used for deposits, you will see that at a moment where you need large amounts, people will create tokens. And then those tokens will literally be used to pay smart contract fees and such, right? So that some smart contracts will create their own token for their fees to be paid in, for example.
Yes.
Right. The possibilities are endless in this regard.
Really, it really makes me wonder how like if you could be really quick at doing this and just you're gonna fire off the financial shenanigans you could pull off if you could get ahead of it. Wow. Yeah, I could see. Wow.
The wheels
Boy.
are turning. So
Yes.
I had a question come to mind earlier. What about the life cycle? Like if I'm talking about an asset, not coinage per se, but a VIN, a car, it has a life cycle, or a cell phone. Then the token is eventually burned when okay, like I take my car, the last 20 years, I take it to the junkyard or whatever. It's that token, the digital twin is burned. Is that right?
It could.
Or it
I
could
think it's
be.
whatever treatment you want to have happen. I think is
Okay.
the answer.
Because the car goes away, then yeah, yeah. Well, I don't know, whatever they do. Oh, actually, I think they destroy the VINs, the
Well,
tag, whatever. But whatever.
it's a
God knows.
little bit more muddy than that, and I kind of know that a little bit.
Oh, really?
Sometimes they
Okay.
go away, sometimes they get
They get
supposedly crushed and get
re
put on a ship to get resold in other countries.
repurposed. That's repurposing.
There's a lot, and that would be off the book, so I'm not sure how that would happen, but certainly you could use the digital twins to help keep that from happening.
Yes, somehow.
But that's the bridge between the physical world and the digital world, and there's always a little bit of an air gap there. So,
Yeah. There's MOBI, the Mobility Blockchain Initiative, and I was on some of those calls, and they were talking about kind of the end of life cycle and what happens, maybe, tokenizing some of the assets within the car, like, that
Sure.
can be reused. And
mhm.
anyway, so
Well,
there's
the
kind of a
digital
spectrum.
the digital twin can be helpful in that regard, right?
Yeah.
So
Yeah,
let's say the car is supposed to be destroyed, but the wrecking yard decides, oh, this is still a reasonable car. I'm going to
Mhm.
sell it in Africa, right?
right,
Yep.
right.
But then all of a sudden that VIN number shows up somewhere,
Mhm.
Yeah.
and then
Well,
you know that this wrecking yard was the last one to have it and
Mhm.
supposedly to have destroyed it. So now they have a problem.
Yep.
yeah.
Yeah.
And you have, where it else comes up is the warranty discussion,
Mhm.
Hmm.
how long am I as a manufacturer on the hook for, it's a liability. Maybe they capture it somehow for the books, or just for the records, to track that. So
No, NTSB, all that kind of good stuff too, right? So
yeah,
all that stuff is sometimes that's required to be followed forever, right? And so it's interesting. Okay, so how are you guys doing? Are you guys ready to call it a night? Are you guys gonna cry uncle? I mean, there are you know, there are
life? Yeah.
There's NFT outputs we could talk about.
I gotta check out myself. I know that.
Okay, cool. Yeah, there's one last thing on off-chain storage, but we can always pick this up later. I think yeah, I think that's probably, this is a good place. We got the secret sauce done. We talked about the foundries, and you guys, I cut out a third at least of what was possible. So just a whole lot there. I want to thank everybody for spending the time with us. Thank you, Eric. Thank you, Dave. Dave has been doing this and helping me doing all these recordings and running the meetings with me. Couldn't do it without him. Phylo, always. Ben, thank you for the help. And thanks for all of you who chimed in and contributed to the conversation. It makes it way easier when we do this. We all learn together and think of new ideas. And that's the whole key, whole reason we're here. So
excellent.
I'm ready to sign out. So thank you for spending the evening or the morning, and we'll catch you in 2 weeks from now.
Absolutely. Thanks so much. Great job. Thanks for joining. Thanks for joining, Eric.
All right. Have a good evening, everybody.
Thanks.
Thanks for organizing, Greg.
You bet. Thanks, Eric.
Thanks, Eric.
Thank you. Bye-bye.